Our next presenter is Muhammad Atif Afzal, and his title is Accelerated Discovery of High-Performance Materials. His major advisor is Johannes Hachmann in the Department of Chemical and Biological Engineering. He loves tennis, puns, and not to be outdone, also speaks 4 languages. So, ready, set, pitch.
Let's consider a scenario. Let's take 2 cups, one made out of a plastic material and another made out of a glass material, and drop them both on a hard floor. What happens? Of course, the glass material breaks, and the plastic material remains intact. You're probably imagining, what if your phone is made up of complete plastic materials? You will never have to see something like that. Well, the problem is the current existing plastic materials do not have sufficient properties to be used in such devices. In my research, I'm designing new plastic materials so that our phones never break. One interesting thing about plastics is that the molecules that can make plastic materials is basically infinite. That means there exists a combination of atoms that can make a plastic material with a targeted property. However, it's a challenge to find the right combination of atoms in this huge molecular space. Therefore, in my research, I'm designing millions of potential molecules and then computationally evaluating them using an infrastructure which is built using complex calculations, and all the calculations are performed on a supercomputer. Now we have evaluated millions of molecules and we have large amounts of data. We can look at the data and understand what's going on with the molecules and how the molecules are behaving. But a human brain can only look at few molecules and maybe design a new material based on intuition, which is what scientists have been doing in the past. But finding patterns in millions of data is quite not feasible. Let's consider a classic example of needle in a haystack. It's nearly impossible to find the needle with our bare hands. But we can accelerate the process of finding the needle by creating robots and teaching them to find the needle for us. In my research, I'm using a very similar idea. I'm creating an automated framework that can basically find the atoms of combination of atoms so that we can design the material with the targeted property. I'm doing this by basically teaching the computers to learn from the available data, which is called machine learning. And the particular algorithm that I use is called neural networks. This is because it works very similar to how our brains are operating. Let me tell you that this technique is being used by tech giants such as Google, Microsoft, and Facebook to do tasks such as facial recognition and voice recognition. In my PhD thesis, I'm extending these techniques so that I can discover next generation of high-performance materials so that our phones don't break. And because I'm using plastic materials, our phone can be flexible, lightweight, and also cost-effective. Thank you.
Thank you, Mohammed.